Ciao a tutti ragazzi.
All right, okay, yes. Calculus 2. What'd you say anyway?
Hello, you guys.
Okay, thank you. All right. So, calculus 2, 3.4 derivatives, logarithmic functions, and that thing's supposed to go away. All right, so okay, math. All right. Recall following statements are equivalent. Okay, so we could change it up. We could change this bad boy right here. I like that. And then we could change it to here. Okay, so we could actually change a power into a log to actually make it a little bit easier to do the derivative. It makes life easier. Okay, just there we go. All right, so right here, you're going to use this thing right here quite often. Right here, when we're taking the derivative of log base a x, so it just gives me 1 over x ln a, where x is greater than 0 because I cannot have 0 in the denominator. Is that a hand over there?
No.
Okay, all right. Derivative of natural log, derivative of ln x is going to be 1 over x. All right, so let's take a look at this one. Okay, so that, wow, good push. All right, so that first one, what do we have? So what rule is that? Chain. All right, so chain, but what could I do with this thing out front? If I'm squaring the whole thing, what could I do with that too? Put it where? In front. Very good. So to be in front, so I'd rewrite it as y equals 2 ln x. And now I could actually do the derivative. So the derivative of this is going to be y prime equals 2 over x, right?
Someone just said yes.
Well, that was just yes. Okay, so 2 over x because 2 is my constant and the derivative of x is just 1 over x, right?
Yep.
Yes. Okay, good. All right, did I screw that up already?
Yep.
Probably.
Okay. Hey, Nick, where were you on that one? Huh?
Wouldn't it be 2L?
Yeah, because
What?
yes, because that one's chain.
I was there right with you, Mr. Patrick.
I know, right? How did I screw that one up so bad?
I don't think you did.
You don't think I did?
You're correct, 100%.
Okay, he thinks I didn't.
I think they did it the dumb way or something.
No,
Rubbing on.
I know, right? I'm still recording too. That makes it even worse. Okay, yeah. So
You're not sure about that.
yeah, so it's going to be chain rule. So 2 ln x times derivative of this, which is 1 over x, which is 2 ln x over x. I wonder if it's equivalent if I did the other way.
Well, that's what I was thinking.
I know, I was wondering that.
Because I was like, I think they just did it a different way, and yeah, it's the same. Because you're just using a property still, it's not like it was wrong.
I know. Anyway, all right. So, what's the base of b? What's base this? If it's just log, what's that base?
1.
Not 1. 10.
10, right? Yeah.
Okay. So if I were to go back a couple things, if I were to look at it, it's log a. What was the other one? Log ax. Right. Yeah. So it's log ax, like this. Okay. So in this case, a is 10, right?
Yeah, because
Okay, so now the derivative, so if I go back to this right here, should be 1 over x ln a. So what did we say my a was? 10. Okay, so it's going to be 1 over x, right? ln of 10, but what about that 1/2? It's a constant, right? So that would just give me 1 over 2x ln of 10. hopefully.
Yeah.
Okay, so next one. What type of derivative am I doing? Implicit, thank you, implicit. So I'm going to have derivative is going to be 1 over x plus 1 over y dy dx equals 2. Move everything to the right. So it's going to be 1 over y dy dx equals 2 minus 1 over x, and then multiply both sides, so it's going to be dy dx equals y, quantity, I know, joy, right? Quantity of 2 minus 1 over x. So if I'm leaving it like that, that's fine. If it's just regular implicit, I would have it like there, and dy dx. Yeah, sure.
Okay.
Okay, yeah. We okay there?
Yeah.
Yeah. Yeah.
Yeah.
Yeah.
Yeah.
All right. I need to make some room for this one too. Yeah. All right. Oh, actually, do you know what? I got another slide right here. I could use this one right here. All right. So the problem is log base 2 x to the third. Log 2 x third. Is it f of x or just y? Okay. So what's my a value in this one? 2. The a value is going to be 2 on this one, right?
Yes.
So now this is the one where I messed up on the first one. Okay, so now since my exponent's here on this one, this is where I messed up on the other one. So the exponent's on this, so this could actually go over here. That would be 3 log 2 x y. So y equals, now it's going to be 3 times 1 over x ln of 2, which is going to give me 3 x ln of 2. Yeah, I messed up on that other one. Sorry. Monday. I know. Someone's having a case of the Mondays. All right. Okay, so right here, if y equals ln u of x, where u of x is greater than 0, a differential rule then by chain rule. Okay, so derivative over that. Okay, so, all right, so let's do this one right here. So chain rule on this first one. What's the derivative of the inside? 5 times derivative of the outside.
1 over
Okay.
5x, right? That's the inside.
Right?
There you go. Oh, dude.
Yeah?
Yeah.
Okay. 5's cancel, don't they? I'm not doing too much voodoo. Basically the same thing for all these, right?
Yeah.
Okay, so now do I need to keep going through this?
No.
No, there's some creepy ones in the back that I want to actually do. I don't even know where that marker came from. All right, 1 over x not equal to 0. Properties logarithms sometimes are used to simplify work needed to find derivative. Okay, so this is the nasty thing I wanted to get to. Okay, so when you see something like this, you're like, what the French toast, right? Okay, but can we break it up? Say yes. Yes. Okay, rules of ln and rules of log. So if there's a multiplication on the inside, what does that mean? It's a plus sign. If there's a division in there, that's a minus sign. So I can break this all up, can I?
Yes, you can.
Okay, so can we do it?
Yes, we can.
Thank you. All right. So it's basically going to turn into ln of 2x minus 1 to the third plus ln of 2x to the fourth plus 1 to the 1/2. Come on now. 1/2 minus ln of x, right? Yes? Yes. Okay, so now let's go through and actually do this. So now the power is actually on that piece right there. So this is the one where, again, I screwed up that first time. Sorry, I apologize. I will kill myself after this, you know, if that'll make you guys happy.
You get demonetized talking about
I know, right? Okay. I know, I just Logan Paul'd it right now. Alright, so y prime is, okay, 3, right? 3 comes out front, and I'm just going to change this to the ln rules, right? I don't want to do that one yet, though.
LN.
Yeah, so hold on. 3 ln of 2x minus 1 plus 1/2 ln of 2x to the fourth plus 1 minus ln of x. Now I could actually go through and do it, right?
Yeah, now.
Okay, now I can do it. Now I can do it, right? You got this. You can do it. All right. Y prime is, okay, so 3 times, what's the derivative of the inside?
1
Say 2.
2, yeah.
2 times 1 over 2x minus 1, right? Plus, okay, derivative of the inside? 8x cubed. So it's going to be 1/2 times 8x cubed, right? Times derivative, which is
1 over 2x to the fourth plus 1.
minus
1 over x.
1 over x, right? Okay, so clean it up. So it's going to be y prime is 6 over 2x minus 1, and that's going to be plus
4x cubed over.
Yeah, kind of like, you know,
Nice. You got that.
and if you want to go through and actually combine all those bad boys, then good for you. I don't want to, okay? Because that's going to be some type of real nasty there.
Imagine doing the board.
Huh?
Imagine doing, imagine Nick doing the on the board.
I know, right?
Dude, start in the middle.
I know, he starts in the middle, like right here.
It'd work out in
and
every
yeah.
direction. It'd be like this weird circle thing.
It's like a spiral.
Yeah.
Okay, using logarithm differentiation, logarithm and the properties are useful. Hey, shut up. Okay, logarithm and properties are useful for finding derivatives of functions that involve products, quotient, powers. Logarithm differentiation uses the following facts. Logarithm of a product is sum. Logarithm of a quotient is difference. Logarithm of a power is product. Man, I'm
You gotta
dying.
sneeze, like.
Wow, man. Okay. Find the derivative using logarithm differentiation. I think this is the one that was supposed to like get all nasty. Oh yeah, this is it. Wait, hold on.
Wait, hold
Yeah, this one's what. You can do it without, but then you're gonna have to like to break it up because right here we have a. If you notice, we have a product on top and a chain on the bottom. And if I do the quotient, I'm gonna have a product chain quotient all together, right? Yeah. Okay. So hey, gotta keep separated. All right. So let's see if we can do this. Let's ln both sides. So if I ln both sides, I could actually clean that up some. So it's gonna be ln y equals ln of that x squared radical 5x plus 1 over quantity 3x minus 2 to the third. Nasty. All right. Okay, so now, because I ln both sides, I can go through and try to
Do the property.
yes, do the property, clean it up, separate all those things, right? So it's going to be, let me see, if I'm going to ln each, so before I do derivative, ln y equals ln of x squared plus ln quantity 5x plus 1 to the 1/2 minus ln of quantity 3x minus 2 to the 3rd, right?
You're right.
So go through and clean it up and start doing my stuff, right? Okay, so it's again ln of y equals 2ln x plus 1/2 ln of 5x plus 1 minus 3 ln of 3x minus 2. And now I can do the derivatives and answer my phone while I'm doing it. Okay, there we go. So we're doing it. We're doing it. Okay, so on the left-hand side, what am I going to get right over her?
2 over.
Nope, right here. Start with this. Start with that.
1 over y.
There you go. 1 over y. And what else am I writing?
dy dx.
Thank you. dy dx equals, this is going to be 2 over x, right?
Yep.
Okay, this is plus,
1/2 times.
okay, derivative of the inside is
5.
5. So it's going to be 5/2 times 1 over 5x plus 1, right?
Yep.
Yes? Okay. And then this next one's going to be, derivative of the inside is
3.
3. So 3 times 3 is
9.
9 over 3x minus 2, right?
We're pretty much done that.
No, because still I got that 1 over y right there. Okay, so we said that, okay, so now I got dy dx right here, but now how do I get that 1 over y over there? Multiply both sides by y, right?
Yeah.
Okay, so now I'm going to have dy dx is equal to y quantity 2 over x plus 5 over 2 quantity 5x plus 1 minus 9 over 3x minus 2 right there. And okay, so for this right here, we're gonna have that y out there, and there was something special I had to do with that y. And so what is y equal to? That top nasty, right?
No.
Of
course.
Okay, but don't distribute it. Just leave it.
Don't distribute.
I know, just write that down, right? Since y is equal to that nasty right there, just put it there. All right, so let's see. So I'm gonna write it over here. So dy dx is equal to, so x squared 5x plus 1 over 3x minus 2 third, okay, bam, and times all that other mess, which is 2 over x plus 5 over 2 quantity 5x plus 1, right? Minus 9 over 3x minus 2. So, that's why I said, I know it looks messy, it looks gross, but I think it's easier than actually trying to do the product quotient there. Product quotient chain. Right?
Right.
Okay, either way, that's what you come up with. What?
Sorry, it was like I was saying. There's a typically like this could be like a 2-parter question. It'd be like find where the slope is 0 now.
Yes. So you just need to F that, right?
Yeah.
Oh, it's actually not going to be that bad. So if you were to do that, okay, so you would multiply. So if this was 0, okay,
Right,
so now this is multiplied, right? So you would get rid of that whole denominator right there, right?
Yeah. Completely.
Okay, so that would all go away. Then we would actually common denominator. The whole denominators would go away because you're multiplying it by 0. And then it wouldn't be too bad. It's just the factoring the top would be a mess. Anyway, all right, we're just throwing you a calculator. Okay, so step one, blah, 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 blah. Okay, and then sub it back in for y, right? That's what it means. All right, so let's do this one again. Okay, so if I was going to do this, it's kind of a mess, right? Say yes. Okay, ln both sides. Okay, so it's going to be ln y equals ln of x to the x. And so now I'm going to do ln of y equals x ln x, right? Yes. Now it's going to be 1 over y dy dx equals product rule. So it's ln x, right? Because derivative of this is 1 times ln x and then plus sign. And it's going to be x times 1 over x, right? So that's just going to give me 1, isn't it?
Yeah.
Okay, so it's going to be, let me see. I have, again, 1 over y dy dx equals ln x plus 1. Now, multiply both sides by y. So it's going to be dy dx equals y quantity ln x plus 1. And what do we say y is equal to?
X to the x power.
X to the x, right? So that would just give me dy dx is equal to x to the x quantity ln x plus 1. So not too bad, right?
No,
Okay, hopefully.
not at all.
Find the equation of tangent line right here at the point. Okay, so same hot mess, right? Okay, so I can actually break up the whole thing again, right? Because again, it's a product in the quotient, so I'm going to try and avoid that. So just go ahead, ln both sides, right? Okay, so that would be ln. So we're basically calling this thing right here y, right? Okay, it means the same thing. So it's going to be ln y equals. Can I just break this up as I go, or do you want me to just
No,
like state it first?
Break it up.
Okay, break it up as I go. So it's going to be ln x plus ln of x squared plus 3 to the 1/2 minus ln of 1 plus x, right? Yes.
Yeah.
Okay, so it's going to be
Thank you.
1 over y ln, dy dx. dy dx equals 1 over x plus
2x over.
yeah 2x, so 2x over 2 quantity x squared plus 3.
Wait, is it though?
Yeah, because the 1/2 goes out front anyway, right?
Yeah, but okay, yeah. But I thought 2x over 1/2 or 2x over 2.
Yeah, that's good. Like that?
Yeah.
Okay, there you go. All right.
I don't know why.
Hey, that got you, right? And be like,
Yeah.
all right, so minus 1 over 1 plus x, right?
Yep.
Okay, so now, finding the point right there, I have an x and y, don't I? It's an implicit, so I have an x and y, don't I?
Yeah. Oh,
Yeah, so do I need to do this little nasty thing again? Say no.
no, we don't.
Do I know the value of y? Say yes.
Yeah.
Yes.
Class, what's y?
1.
1. It's 1, right? Okay, so that's what I'm going to do. So see this little nasty right here? That turns into 1 over 1, right? So I don't even have to worry about plugging it back in and doing all that, right? So I have a y value, so I'm going to get dy dx is equal to 1 over x, which is 1 over 1, right? Plus x, which is going to give me 1, right? Over 1 plus 3 is 4. Did I hear 5? All right, so minus 1 over 2. So the slope on this one's going to be, let me see, 2 over 4. So it's going to be negative 1/4. Negative 1/4. And this one right here, so that is 4 over 4, positive 3/4.
Yeah.
So dy dx is 3 over 4.
Into our equation.
Okay, so Are we okay, or did I do that a little bit too fast? Because fractions are my friends.
It's a good day when I get it.
Yeah! Fractions are my friends. All right. So is today a good day?
Yeah.
Oh, good then. Okay. So dy dx. So that means that the slope of this thing is 3 over 4. And now what is it asking for? Equation of the tangent line. So we have the slope and we have the point. So 3 over 4, let's see. So m is equal to 3 over 4. My point is 1 comma 1. So it's y minus 1 equals 3 over 4. Quantity x minus 1. So y equals 3 over 4x minus 3 over 4 and plus 4 over 4. Where did I get 4 over 4?
The 1.
So I added 1 to both sides, right?
Yeah.
So I added 1 here, and I added 1 to here, and my 1 is 4 over 4, right?
Yep.
And I like fractions, because I could just like make them work. All right, so for this one, it's going to give me y equals 3 over 4x plus 1 over 4 is the equation of the tangent line.
We did it.
I know, when you get that problem and you're like, yeah, this is American. All right. Okay, proving this one, no, I'm good. No, I'm good with that one. Oh, how about this one? Okay, how about this? So this will give me what? Wow, did I lose everyone here?
We're still doing the.
Yeah, let's do this thing. No, don't do that.
No.
Don't do that.
Not here. It's not.
Don't do that. Okay, what would you do? Just say rad 2.
I was gonna say, would you bring the rad 2 down?
Yes, rad 2, right? It's a number, right?
Yeah, no.
X
Rad
raised
2.
to the,
Add 2 minus 1.
there. I'm not trying to make it all crazy, right?
Right.
Okay, so now,
Same thing.
wait, that's prime, sorry. Y prime would be
First we take the pi down
pi,
times the derivative of the inside
No, times the
This is the
inside.
original.
times, okay, my bad,
x squared plus 1 raised to the
pi minus 1.
pi minus 1 times the derivative of the inside, which would be
2x.
2x. Okay.
They just do it a certain way.
Not bad, right? Not trying to confuse any. Oh, yeah, hell no, I ain't doing that. Nope. Done. All right.
Awesome.
Yeah, why?
All right, there you go.